So 2.3 is a pretty short section. All we're going to talk about is some methods and tools for measuring length, volume, and mass. So our aim for this section is to understand the metric system for measuring length, volume, and mass. So remember we talked about why the metric system was more appropriate than the system we currently use. So we want to make sure we're using the metric system that is centimeters rather than inches, for example, specifically for length, volume, and mass. So we're going to work one row at a time, going across the table, starting with length. What does length measure? Length measures distance. So if you have a length in kilometers or miles, that is measuring the distance from one point to another. What is the base unit of distance? And remember, we're talking about the metric system. That would be the meter. You can adjust it from there with your metric prefixes and say something like centimeter or kilometer, but the meter is the base unit. And just to think about some of the different tools that we use to measure length, we can use something like a ruler, a meter stick, a tape measure. So that's length. Volume. You can think of volume as something that fills up a cup, but what's inside that cup represent? That's the three-dimensional space that an object occupies. So remember, we can have a square that would represent two-dimensional space. We've got length times width, but we're looking at something like a cube if we're looking at an object's three-dimensional space, because now we have three dimensions. We've got length, width, and height. So we're looking at three dimensions rather than two. What's the base unit of volume? We can use the meters cubed, which is the same thing as a liter, or we can use centimeters cubed, which is the same thing as a milliliter. And which one we use depends on what we're measuring. So let's take a look again at the cube. If we're looking at a cube, which would be a solid structure, that would mean we have three different sides that we need to measure. If this side were measured in centimeters, and this one were measured in centimeters, and this one were measured in centimeters, we know that length times width times height is how we measure volume. And in multiplying all of these together, we would be looking at centimeters times centimeters times centimeters, or in other words, centimeters cubed. If you've ever watched a hospital drama, they usually say, I need 10 cc's of whatever drug it is they're talking about. That's exactly what they're talking about. cc equals a cubic centimeter. So they may as well just say milliliters, but they use cubic centimeters instead. And then liquid would be something measured in liters or milliliters, because that's more easily measured using something like a cylinder. We don't have three sides to anything that's in a cylinder. Instead, we just measure the volume in terms of the graduations on whichever device we're talking about. So what tool do we use? If we're doing a solid, we might use a ruler. If we're doing a liquid, we could use a beaker or a graduated cylinder. And then finally, mass. Mass measures the amount of matter. And what is the base unit for mass? That's the gram. So again, apply your metric prefixes. You can turn this into things like kilograms or milligrams or centigrams, as long as you're adjusting the power of 10 appropriately. What tool do we use? We use a scale or a balance. We tend to use digital scales in class. You may have also used a triple beam balance. And a triple beam balance usually has a balance pan, and then it's got three beams on the side, and you operate those similar to a scale that you would see at the doctor's office. It's got three little levers on it that move back and forth and adjust to the weight that's put on the pan. We have these tools in the lab too, but just for convenience and for ease of reading, we tend to use digital scales, but they're both pretty accurate. Measurements come out pretty much the same, whichever device you choose to use.